In this demo, we will learn how to configure a grid file to be used within the MATLAB ROM's numerical toolboxes, or in short, the RNT toolbox. So to do that, we're in the home directory. We're going to go back into ROM's grid, okay, where I have prepared an example file, okay, that we're going to edit. First, let's run MATLAB, okay. So right now, in the previous example, we created a grid file that we stored inside ROM's examples Coriolis input, Coriolis grid. So this is our grid file here. Now in principle, if I wanted to load this grid file and information concerning this grid file, I can open this file as a netcdf file, okay? And that would be one approach that I would take, and I would put this name file here and then open it like this, and then I could say I want to load the topography, for example. I would load the topography, okay, and this would be an example of loading the topography, and then I would have my topography here. However, in general, there's so many parameters of the grid that it would be handy to just load all the parameters of the grid at once. To do that, there's within the RNT toolbox, which is the ROM's numerical toolbox, there is a function called grid load, and this basically allows you to load all the information of a grid all at once. So for example, if I do grd, I define a variable and I load a grid. For example, I have already some grid configures for you. WRD is a grid of the world, and I just type like that. Now what I have here, I have a structure array called grd, and this structure array contains all the parameters of the grid. So for example, grd.id is the ID of the grid, grd.name is the world, grd.grd file gives you the full path to the grid, and so forth, and the number of layers, some information about the parameters of the vertical coordinate system, which we haven't discussed yet, but anyway, it's there. The coastline file that it's going to use during the plotting, the longitudes, the latitudes, the kilometric coordinates in x and y, the topography, and so forth, and the number of grid points, LP and MP, and so forth. So that's kind of nice, because now, for example, if I open a MATLAB figure here, which I'm going to put here on the side, and then I do rnt underscore plcm of grd.h, which is the topography. This is a plotting routine, and all it needs to know in order to do the plot is to need to know the grid that you're operating on, and you just type return, and it plots your grid. And the nice thing is that you can load other grids very quickly. For example, suppose there's also a grid Indian Ocean. You do that, and at this point you can just plot the Indian Ocean. This is the Indian Ocean, the Bay of Bengal, and so forth. So this is a very handy thing. So how do I now configure my grid so that I could load, in principle, my Coriolis grid by just typing Coriolis? If I did that, it would say that there's no such grid. So let's close this MATLAB. In order to configure the grid, there's a file called rnt grid info. Okay, you do a which, and it's tell you the absolute path of where this file is. So let's open this file and let's configure our grid. So let me close here. Okay, so I'm opening this file. This is part of the ROM's numerical toolbox. And if we go down, let's go and find, for example, the case of the world. So you see here there's a case world, and then there's all these parameters that are initialized in this file. Now, for example, there's another case, the North Atlantic NATL, and these are all the information of the North Atlantic grid. And then there's a grid for the Labrador Sea. IAS is the Intra-America Seas at 20-kilometer resolution, the North Sea. These are all predefined examples that of grids that are available to you right now if you want to load them. But these are also serve as an example of how to configure grid. So I'm just going to go at the very end of this file, and you can see there's a whole bunch of different grids, including Peru, the SCB, which is the Southern California Current, the Northeast Pacific, and and so forth. Okay, so I'm going to go to the very end, and I'm going to just copy an existing grid. Okay, F12, and I'm going to call this Coriolis. Okay. This is going to be, I'm going to put a characteristic name for me, so I know this is Coriolis, this inertial oscillation. This is the name of my application. Now I have to put the path of to the grid. In this case, if the grid is not in your MATLAB path, you need to actually put the entire path of the grid. So we're just going to put it here in parentheses. Let's go and look for the grid. So I'm going to open another window. If I go in my home directory, I go in ROMs examples, and I go in Coriolis. Okay, and I go in input. Okay, so my grid is going to be in this directory. Okay, which I can copy, and the name of the file is going to be the following. Okay, so this is the whole path to my grid. So I'm going to select this. I'm going to go back to this directory here, and I'm going to insert it over here. Okay, so now I have the grid file, and so I don't have to worry anymore where it's located. I'm going to say how many vertical layers the grid file has. In this case, if you remember the Coriolis application, it was 16 layers. And let's double check that. So I'm going to put 16 there. Now let's go here in the home directory, in the ROMs source code. Then we go and we open the mod param files, which is the one that has the number of dimension, the size of the grid. We look for Coriolis, and in fact, if you look here in the Coriolis part of the grid parameters, you find that n in fact is equal to 16. So that's good. So we want that to be the same as here. And then for the vertical coordinate system here, we haven't done that yet, but this information is actually typically stored in the parameter input file, that is in the examples directory in Coriolis. We go in input, we open the Coriolis.in file, and this input file, this is the one that is provided at runtime, has these information like theta. Sorry, let's go forward, we'll find this. There we go. So these are the vertical coordinate system, which is called the vertical S coordinate parameter, and these theta S and theta B here are both 0. Okay, so we go back to our configuration file here, and so these will be both 0. Okay, but in principle they are not always 0, so you always want to make sure that these parameters are the same as the ones in the grid file. So now I can save this. Okay, and if I go back to my MATLAB window, and now I do GRD Coriolis, now suddenly you find that your GRD array is no longer giving you an error, but it's populated with stuff. Okay, and you can see that if I look now grd.h, which is topography, I have my topography here, and I have other parameters like the f parameters and so forth. So I've loaded all these informations. Okay,